Okay, so first of all, the questions I'm about to ask, this is exactly what your real test is about to look like. This practice test is your real test with different numbers, different things filled in, and you're taking the test today, right now. So everything I'm saying right now, literally using this on the test is allowable. So I'm looking at this vocab and this wants me to just match some words. So do I know what an arc is? Can I visualize that on a circle? An adjacent arc would be two arcs next to each other. Can I picture a central angle that starts at the center and goes out on the circle? Can I picture a chord, a little line drawn across the circle? Can I picture concentric circles? That's drawing a circle, inside a circle, etc. An inscribed angle, can I picture that? Starts at the edge of a circle, drawing that angle. Can I picture an intercepted arc? That's the two pieces it touches. Can I picture a secant? Here's where we start going, wait, is that the same as the chord or is that different? What's a sector, the wedge of the pizza, look like? A segment of a circle, a tangent of a circle, and tangent circles. These are the possible words you could get. Some are fake and some are real. So Aiden, just to be clear, you are working on your 5.82 Apex quizzes if the study guides need to get done watching those videos, okay? So looking at the first picture, picture number 1, I'm starting over here at Isabel and we're going to go down the row. So Isabel, that picture that's drawn goes with one of the vocabs above. Notice there's only 4 lines on the right. We're only picking 4 of the words. I gave you way more than you need. Do you happen to know when that line is drawn and just touching in one little place, what that's called? A tangent of a circle. Go write that down. So what letter goes with that? Good, she got it. This one right here is the tangent of a circle. Now, they didn't get it right yesterday's class, and would you have gotten that right? So make sure you label this as you need to in case you get one picture of tangent. All right, I'm moving next to Letzi. You've got number 2. Do you remember what that picture is? This little line right here. It is a chord. Oh, man. You guys are doing good. So a chord stops at the edge of a circle versus a secant. If you want to draw one, just to be clear, a secant touches twice also, but it goes all the way through. So those are the two that kids normally confuse. So do you want to draw that in somewhere to remind yourself what it is? A secant keeps going through the circle, still touches twice. A chord for sure stops. Do you guys see that difference? Here's my chord. Secant keeps going. Okay, looking at number 3, I'm over to Esmeralda. Esmeralda, this is a kind of angle, just like number 4. Do you remember the name of this angle? Remember, it's okay to say, I don't know, you guys, if we don't know. This is a central angle. What letter is that? Yes. Notice on this test, you're going to put all your answers in an answer column on the right-hand side. This one is C, a central angle. And finally, I'm going to move down to Sierra. Sierra, do you remember the name of the number 4 angle? It is. And what letter is that? The answers were K, D, C, F. Does anybody have any questions on those? Okay, going down to the next one, it says which one is the tangent of a circle? And you might get one that says which one is the secant of a circle, so you want to make sure you know those differences. I'm up to Leo. Leo, we have a hint given to us sort of towards the top. Do you see which one? The answers are either A, B, C, or D. Which one is the tangent of a circle, Leo? Do you think it's this guy that's a tangent? You think it's this guy? This guy is actually the secant. Do you see how that's the one that kids get confused by? So a tangent touches in one place on the edge of a circle. Which one has it touching one place on the edge? A it is. So do me a favor, label it as you need to, Leo. This one's the tangent, this one's the secant. What's the middle one B? Does anybody know that one? It's a kind of chord. It's a special kind of chord. Does anybody know that one? Are we just being shy because it's not your turn to talk? That's our diameter when it goes straight across the center. Did anybody say that or whisper it or think it? You got it. Okay, good. And then how about D, in case that's the one they asked me about? You guys know what that one's called? That one's a chord. Okay, so if This one said, identify the chord on your version of your test, you would have picked D. If it said identify the secant, you would pick C. If it said identify the diameter, you would pick B. Does that make sense now, how it's still a vocab question? Okay, going down to our first calculation, and I'm at Chloe. Chloe, there's two things we need to know to be able to solve this. And let me just tell you guys, on this test, it comes up over and over and over again that you have to know that a whole circle equals 360. Because if I can get all these parts, then I can find the missing part too from that 360. So Chloe, I have to know something, and they told me that MT is a diameter. That's a hint about how many degrees is on that side of the circle. Do you know how many degrees is on that side of the circle? Because that's a diameter?
That's a semicircle, so it'd be 180.
Boom, write this down. We write semicircle equals 180, and that fills in this. Now there's a 42 on this central angle, Chloe. And there's a statement that says central angle equals arc measure. So what's the actual measure of AT?
42 degrees.
Also 42. Look how I'm labeling it and working straight on the circle, straight on there. By the way, if you're writing this in your math notebooks, you're like drawing it if you need it, or just writing whatever notes you might need for yourself to help yourself on the test. So if I know this is a 180 and I know this is a 42, can I find that missing piece now, Chloe? What am I going to do?
So what I did was you do 360 equals 180 plus 42 plus arc of MA.
Like that? Or plus?
Yeah, I did plus.
Sorry, there we go. And then when you added 180 and 42, what did it give you?
I got 222.
And then when you subtracted that, what did you get?
The degree of 138.
And she got it. So a couple things are going to happen when I grade this test. If you got the 138 degrees answer, you're going to get a point. Like no matter what happened, if there's nothing else written. But I'm looking for work. I'm looking that you're prepared for Math 3 because your counselor sent me a list and said, hey, here's what they signed up for next year. And I get to go like this. Oh, no, they're not taking that. Or, yeah, that actually really makes sense. So show me you're a Math 3 student by showing me as much work as possible. If you're thinking, should I write this down too? The answer is always yes in Math 3. You show all of your work, all of your justifications. And so all these things, I needed whole circle is 360. I needed semicircle is 180. I needed central angle equals arc measure in order to solve that. Any questions on that one? I'm scrolling to the next page. Now, just another comment. Remember that this little piece is called a minor arc and a bigger piece is called a major arc. That vocab didn't come up at the top, but we should know those as well. Okay, scrolling down to sector. Now, notice this doesn't go in order. Like Apex is like, here's your 5.2, here's your 5.3. This is just throwing it at you in any specific order. I'm also going to tell you which ones are extra credit and will be extra credit on your test too. If you like watch me do it right now and go, oh, I get that. Even though I didn't do the extra credit, you can try it on the test if you have time. Okay, area of a shaded sector, and I'm over to Thomas. So area of a sector is going to be my part. I'm going to call this AB because they didn't give us any letters. My part of the whole 360 times the full circle's area, which is pi r squared. So how do I calculate just my wedge of the pizza? I'm going to do my part of the 360 times the full circle's area. So let's go plug in, and I'm at Thomas. Thomas, what is my part? How many degrees is my little section, my little wedge?
110.
Good. That's going to be my numerator in my equation. And then that's my part of the 360. What radius did they give us, Thomas? Also in the problem. And that gets plugged in here. Now, 6 times 6, you guys, that's my 36 pi. That's my full area. And then I'm going to reduce this fraction. Thomas, can you think of anything that goes into anything that ends in a 0? What could I divide into both the top and the bottom? Do you remember this little trick I showed you like that, Thomas? It's called dividing by 10. Anytime it ends in a 0. Were you thinking 10? And so we're going to go 11 over 36 as my reduced fraction. Now, if you multiplied 11 by 36, do you guys remember the 11s rule I taught you? 11 times 36, any two-digit number. Do you remember we split the 3 and the 6? We add it together to make the 9. You could get 396 pi over 36. But do you guys also remember we can just cross-cancel? 36 and 36 divide out. And so we can cross-cancel that and save ourselves these big multiplies, where I say to myself, cross-cancel the 36 and the 36, and this just gives me 11 pi. What are my units, Thomas, this time? Is it just U for units squared, or is there an actual feet or inches or something given?
Centimeter?
Yep, centimeters squared for area. This is called my exact answer. Over on the line, we're going to write the exact answer and the approximate answer. I'm going to jump over to Isaac now. Isaac, can you multiply for me 11 times? Now, you guys have some options. You're Math 3 students already, right? If you're passing this class, you're going to Math 3, whether you think you know stuff or not. So do you want to use the pi button like grown-up Math 3 students now? It's not Apex anymore. You can actually use the pi button. Or do you still just want to use 3.14? You're going to still get credit no matter what. So you do you. Go ahead and do 11 times 3.14 for me, Isaac, or 11 times the pi button, and tell us what you get. And that's going to also be centimeters squared. You're going to give me both the approximate and the exact answers over on that line. That was called area of a sector. That was section 5.8. If you want to put a little note to yourself, 5.8, it means you could go back and look at your 5.8 notes if you're confused on something like that on the test. All right, we're going down to arc length. This is going to be from 5.7. And you're going to notice it looks kind of different than the apex problems. The apex problems were like this, where they had the radii attached. But in this case, it doesn't matter. And it throws it in like this, and people freak out. Which is this? I've never seen this before, but you got this. So Aiden, are you doing study guide or just straight to apex? Okay, perfect. So what part of my whole circumference is going to be my arc length? Let's write the formula first, and then I'm at Danny. Danny, my arc length formula is just like area of a sector, where it's the measure of my part, sorry, this time they did give us letters, UV, of the whole 360, times the whole circumference instead of times the whole area. So this just wants a piece of the arc, meaning a piece of the whole circumference, versus the wedge, the actual shaded sector. So what is my piece this time, Danny? 50 out of the 360. And then what's my radius? Okay, when I multiply and get the full circumference, what's that going to give me? We're going to just do the 10 pi first. And then 5 over 36. And then if you multiply that out and reduce it, what did you get as an exact answer? Good. Do you guys see how he got 50 over 36 and then divided by 2? So he's getting 25 pi over 18. And what are my units this time, Danny? This is known as my exact answer. I can't reduce the 25 and the 18 any further, so I'm done. So now you're going to multiply that by pi for me, Danny, and tell us what you get as the approximate answer. 3.6?
Yeah.
Please don't forget those units, you guys. Please, please, please. They're like unit Nazis in Math 3. They're like, which teacher did you have? If you don't put units, and then they go like this. See, I knew Miss Sanchez didn't teach to write units. So please write your units. It literally gets marked off, every little thing in Math 3 for you not having all these parts. I'm not trying to scare you. I'm trying to let you know it's going to be a whole new world next year. Okay, that was finding the arc length. The arc length, and we did area of a sector. That's sections 5.7 and 5.8. we're now moving down to one of the extra credits. So for example, if you're like just trying to get by and you're feeling already like you need a break, this would be a great time to go take a break because this is an extra credit and you don't have to do it. It means on the test, I'm going to tell you, highlight this one, it's extra credit, and you can skip it if you don't want to do it. So please write a big EC, extra credit, next to this one, or highlight it so you're reminding yourself that this one is extra credit. So why is this one extra credit? Because it's making us work backwards to find a radius using this same arc length formula from before. It just takes a little bit longer for some people, so I'm trying to save you guys time. So we start with the same formula from the one before. It's going to be the measure of EF times 2 pi r, but this time they give us the arc length. They actually tell us the answer. They tell us that this is an 8 pi. And Danny, I'm going to have you continue on this one with me real quick. So what's my measure? What's my part of this one, Danny? Yep. And then this time, they don't tell me the r. It's what I'm solving for. So I've got to work backwards on this one. So I could reduce 120 over 360. What fraction is that, Danny? Does that just come to mind for you? I'm thinking it's 1/3. Is it 1/3? 12 goes into 12 once, 12 goes into 36 3 times. It's just a 1/3. Oh, I see why you said 2/3, because you're already multiplying by the 2. Do you guys see how he saw that 2 there already? So it's 1/3 times 2 pi r, which turns into 2/3. Now we need to get rid of that denominator, Danny. What am I going to multiply to both sides? Times 3 times 3. I'm going to now move my work up here to the top box because I'm running out of space. 3 times 8 pi is 24 pi is equal to 2 pi r. Did you guys know you can divide out two things at once? I can divide both sides by what, Danny? Yep. And what's my radius going to be? Now, they didn't tell us any units or anything here, the length of a radius. You could put U for units, but I'm just going to be happy if you have a 12 on that one. So, extra credit. How do you feel about it? Are you like, ew, that sucked? Or, yeah, it all made sense. You're going to decide on the test. What I recommend on the test is do the real ones first. And if you have time, go back and do the extra credit. Does that make sense? Like save them for a last if you have time. Thank you, Danny. I knew you could do that one fast for me. I'm back to Leo for the next one. Leo, this is going to be both our inscribed angle theorem. So let's write that first before we start working on it. This is inscribed angle theorem. Now, what does this word inscribed even mean? It means drawn inside a circle. Inscribed. You could have inscribed polygons. You could have inscribed angles. You could have an inscribed triangle. It just means drawn inside. So my inscribed angle, here's the rule, Leo. The angle is half of the arc. The angle is half of the arc. That's the rule. So looking at the y, Leo, what would I do to the 94 to get the y? What am I going to do on my calculator? 94 what? Divided by 2? I can't tell what you're saying. It's dividing it by 2. Grab a calculator for me right now. Take a 94 and divide it by 2 and tell us what you get. And then Chloe, you're going to do the reverse. I'm going down your row. You're going to do the other one in reverse, the converse of where you've got the 42 and you've got to go out. You got it. The y is 47 degrees. Remember, we're back at degrees when we're talking about measures of an angles here or measures of an arc. So Leo, that's it. If I want to know that angle, you just take that arc and divide it by 2. It's half of that intercepted arc. Cool? So I have to write the reason, inscribed angle theorem, and then I have to show what I'm taking half of. And then Chloe, we're doing the reverse, the converse for the other one, where this time I gave you that half angle, but I want the intercepted arc. So instead of dividing by 2 this time, Chloe, what do I do to get x? Yep, and we get? Good. So look at the work I'm going to be looking for on this one. I'm looking for you to write that inscribed angle theorem. I'm looking for you to know when do I double it and when do I half it. And I think of it as a little tiny angle, it's getting bigger. That's how it, doubles. So if I'm going from the arc into the little angle, I half it. If I'm going from the little angle out to the big arc, I double it. To me, it looks little and then big, so it makes common sense. Okay, that was not an extra credit. That's a for sure required inscribed angle theorem. Are you guys okay? All right, next one. It's telling me that SDU, okay, when I read that, I literally highlight it or I touch it with my pencil at a minimum. I go SDU is 78. Please label it right now. Angle SDU. They're telling me in the problem is a 78. Leo, go take breaks if you need them, all right? This is an 85-minute period. If you need it, go take one. So this is 78. I know central angle equals arc measure. I'm over to Imogen. Imogen, if I know the central angle is 78, what's that arc measure? They're just equal. So this is a 78, so what's my arc measure? Also 78. Literally, the central angle equals the arc measure. It's that easy. So since I know that angle, it was given to me right here, I know the arc measure as well. Now that I know that arc measure, what are they asking me for? They're asking me for SYU, an inscribed angle. So I'm using two things here. I had to know that the central angle was equal. Now that I have that arc, I'm just going to what it. I'm still at Imogen. Imogen, if I'm ignoring the yellow angle for a second, if I'm ignoring the yellow angle and I'm just going for this green one now, what do I do to that 78 to go in? Divide it by 2. Get me that number. So I'm going to go measure of angle SDU is equal to half the measure of the intercepted arc Good. And what are your units? When we're doing measure, anything with a little m, you're going degrees. You're going degrees. Okay, that one had this was like that circles homework that I gave you guys over the weekend, and people were like, whoa, what is this? It's where there's a central angle and an inscribed angle inside. It's kind of tricky. So you have to see both. I'm ready to go to the next page whenever you guys, and then I'm going to go over to Sierra. Anybody need more time on this? And I'm going to be attaching this full key so that you guys can see it during the test. Yes, Imogen? More time. Okay, good. Give everybody more time. Imogen, tell me when you're ready. Okay. Angle in the circle below, the measure of PR equals 140. Again, when I read that, I go highlight it and I go label it. PR is 140. Go ahead and write that in there. Next, it told us, come on, that the measure of angle RPQ is 50. Go label that. Go label that. That right there is a little hint on something about the arc. All right, so if I know this, what kind of angle is this, Sierra? If I know this, what can I get? It's not central, so central would be here. But what's the other one called? Inscribed angle. So everybody write that down, inscribed angle theorem. And inscribed angles are half of their intercepted arcs. That's the rule. And we have a cheat sheet, which I'll refer to in just a second. So Sierra, if this is a 50 and that's half my intercepted arc, what is my intercepted arc? You're going to go reverse from the little angle to the big arc. What am I going to do? I'm going to double that. Beautiful. Oops. That becomes 100. So if I know that's 140 and I know that that's 100, so I'm going to go measure of RQ is 2 times the 50 by inscribed angle theorem. I got that that was 100. If I know that's 100 and I know that's 140, and they're asking me, so check this out right here. They're asking me what's the measure of PQ. What can I do as my final step? So if the whole thing's 360, Sierra, what am I going to do to find this missing one? Yep. Now you can do it how Chloe did it, where she set up the nice math 3 formula, equation, I should say, or you guys can just literally go 360 minus 140 minus 100, or some of you are like, it's 240, and you can just subtract 240 at once. And what does that give you, Sierra? 120. Now, do you guys see how this one's a multiple choice, how the answers are there, and you might not have even noticed that? So you can double check like, oh, there's my answer, and write D, or D and the 120, etc. Any questions on Sierras? Okay, start looking at the next one. The next one is an extra credit. Again, if you were like dying for a break, this would be a good time to go take it if you don't want to feel like doing an extra credit. I'm moving on to Esmeralda. And I'm going to pause for a minute to make sure you have this open. Can everybody go click in Google Classroom, click on our practice test bin, and open up the Math 2 Unit 5 justifications page. If this isn't already open, this is like gold. This is going to get opened. Now that picture of the extra credit one we're doing is on here. It's why we want to use this. I'm going to scroll down. Which of these bottom pictures looks like those two secants going through? Does everybody see how there's two lines going through a circle, touching twice, touching twice? This is called the secant angle theorem. This was section 5.6 that I told you guys was extra credit. I said, go do it if you want to. And a lot of people did it. So now that we know that, how do I get back to this when there's no screen? Okay, so go ahead and write that. This is the secant angle theorem. Now, what do kids confuse? Which two do they confuse? They confuse when the two lines go through the circle like that. This is the secant one that we're doing now. And they confuse the tangent when the line touches once and the line touches once. Look at how close those are, but one goes through and one doesn't. Here's the good news if you confuse these. They use the same rule. Doesn't matter if they go through or they just touch once. They use the same rule. What is the rule? It's that the angle is equal to half of the big minus the small arcs. That little angle, this guy right here, is equal to half of the big minus the small. So my big is going to go here. My small is going to go here so I can get my angle. Was I on Esmeralda? So Esmeralda, they're asking us for the measure of CEH. When they ask me for something, I go touch it or I highlight it to make sure I'm getting the right thing. To get that angle, I use the secant angle theorem. And so here I go. The measure of angle CEH is half. What's my big intercepted arc? 84. And what's my small? Can you subtract those for us, please, and tell us what you get? And what's half of 56? My angle is 28 degrees. So whether it's the secant, or the tangent, or one of each, it uses the same rule. It's half of the big minus the small. It's not a hard rule. So you might want to do that extra credit. I don't think it's bad. All right, the next one. Given that the measure of CBD equals 25, CBD equals 25, go draw it in. I'm going to do this one really quick because this is also an extra credit. So since I know that inscribed angle is 25, I know that the intercepted arc is 50. And since this right here is a diameter, does everybody see this diameter? I know that this is 180. Does everybody see how I saw that that was 180? And I took that 25 and doubled it. So I can go 360 minus 180, and I can go 180 minus 50 and find the missing piece over here is 130. Do you see all these things they assume you know? Because I know this, I can get this. Now, what's the extra credit rule? If I go back to my little cheat sheet chart, where did I put it? And I scroll down and look for one that looks kind of like an L. It's this guy right here, tangent chord angle theorem. And it's just like an inscribed angle. It's half of the intercepted arc, that missing 130. So I'm going to go write tangent chord angle theorem. Tangent chord angle theorem. And I know it's like an inscribed angle. So to find this guy right here, I'm going to use this formula. So the measure of angle CBR is half of that intercepted arc. It's just like inscribed angle theorem. It's kind of like a sideways inscribed angle. I look at it like that. So half of 130 is 65. Remember, this is extra credit. If this one feels over your head or your brain is like dying this far into the game, it's extra credit. Any questions on that guy? So again, that's right on your cheat sheet to use if you have time to do it. Anybody need more time on that guy? Give me just a thumbs up so I know you're still writing. Thank you. Okay, this next one, 23, is the same as what we just did as far as the rule we just used. So I'm going to write same as number 22, but for time purposes, there's an actual typo down here, so the answer is not even there. So if somebody did this at home and your answer wasn't there, you're good. There was a typo. And so since it's the same as the last one and it's extra credit, we're going to skip it and do the last three. Okay, this rule right here, it's the only one where you sum the arcs. The other two extra credit ones are where you subtract the arcs. This one, we sum the arcs. So this rule, let's go back to our little cheat sheet and see it right here, intersecting chords angle theorem. Right there in the middle, looks like an X through your circle. So go write that. It says that it's half of the sum of the arcs. It doesn't matter which order if you add the big or the small this time. It does matter when you subtract that it is the big minus the small, or you get a negative. So intersecting chords angle theorem. And this says that the measure of ABD is equal to half of the two arcs. So what are those arcs? I'm over to let's see. Let's see, what's my first arc? Good, and it doesn't matter which one you do first this time. And then what's your second arc?
45.
Good. So do 100 plus 45 for us, and then divide that in half to get our answer.
72.5.
Yep. Was it 3 or 72.5?
72.5.
72? I just couldn't hear you. Sorry. So 72.5 degrees is the measure of that little vertical angle in there. Okay. So there's not any weird, like on Apex, they would actually be asking you for this other angle, the one that's not related to the arcs. We're just going straight forward on this test, the one that's inside. Now we're finishing off with the circle formulas. This was section 6.5. Lots of you, I don't know if it's you, but lots of period 5 didn't even do this quiz yet. You have until Friday at 1 o'clock to do your makeup work for this chapter. It's several days after the test. You're welcome. It's all going in as zeros if it's not done by Friday. So please try to get any makeup work done by Friday. Okay, what did 6.5 say? 6.5 says if I have a radius and I have a center, then I can draw a circle. If I have a circle, I can get the radius. I can get the center and write the equation. So here I go. I'm at Isabel. Isabel. Starting with the formula, please write this down. It goes x minus h squared, y minus v squared equals r squared. The h and the v is my center. The h and the v are the two coordinates of my center, like 2, 3. And the radius is at the end there. It's that number at the end. We're going to square root it. And that's it. Like literally, this is my favorite section to teach because you guys usually pick this one up, even if I teach it to you right this second. So taking that radius at the end, if it's r squared is 25, what would my radius be? That's it. My r is 5. Do you need to make yourself a little note like r squared equals 25 and show the square rooting? I don't know. You do you. Then what's my center? Now, this goes back, Isabel, to point slope form and vertex form. And anytime we have an equation in parentheses, this sign is opposite of the point. So if this says x minus 3, what's my actual h? Is it 3 or negative 3? It is positive 3. So what do you want to write to yourself right now? Opposite sign. Remind yourself, if it's an x minus 3 in the parentheses, it's a positive 3 in the point. And so Isabel, after you finish writing yourself that note, when it says y plus 2 for the y, what's that actually going to be? You got it. She's not getting faked out now. It's the opposite sign for both, just like vertex form, just like point slope form. It's 3 comma negative 2. Now you're going to go draw me that circle. Go 1, 2, 3 to the right, go down 2, and put your center. That is the center, your starting point of the circle. You then go do your radius, which is going to be 5 in all the directions. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then do your best to connect it. If it looks funky like mine, you still get credit. So you're going to have to pull out the radius, pull out the center from that equation and draw it. Or are you going to be okay? There's literally one just like this. Last but not least, they have us go backwards. Can you go forwards and backwards? This time, can you please get me the radius by counting on the graph? I'm at Chloe. Can you please get me the center by going and looking at what coordinate that is? Chloe, are you ready? How many is the radius?
I said it was 4.
You got it. And then my center is at what?
I said negative 1 and 3.
Good. Now in writing the equation, let's go plug it in. It's the same equation we wrote above. Go for it.
X plus 1 divided 2.
So do you guys notice how she just said x plus 1? Because the formula goes x minus a negative 1 and turned into plus. It's the opposite sign. I love it. And then what's going to be for our y?
Plus y minus 3 to the power of 2.
Notice she said y minus 3 to the power of 2. And by the way, we say that as quantity squared in Math 3. And then this is going to be equal to r squared. So what's it equal to? You got it. Some people like to write equals 4 squared and then a step below, and some people just write equals 16, and it's beautiful. Our practice test is done. I'm going to download this and attach it after I've passed out your test in case you need to refer to mine because yours looks scribbly on your papers. Any final questions before we take the test? Yes, it's happening right now in this period. Okay, it is open notes. It is open cheat sheet. It is not open phone.